Hey everyone, today we're going to move away from ions and ionic compounds, and now we're going to name the other side of molecular compounds that we learned in Chapter 8. So it starts off with a picture of a woman throwing a spear, and it says, what numerical prefixes are used in chemistry? Well, the word triathlon contains the prefix tri, indicating 3. So whenever you're in a triathlon, there are 3 things you are going to be doing. Prefixes are used in chemistry too. Think of the word bicycle, bi meaning two wheels on a bicycle. Okay. So what are molecular compounds? Let's kind of review that from Chapter 8. Molecular compounds are compounds composed of molecules that are held together by a covalent bond. So what are molecules usually made up of? They are typically between 2 nonmetals or metalloids. One thing to look out for is they do not contain metals or any kind of ions. So you will not have an ion, a polyatomic ion, and you will not have any metals. If we were going to start off by learning how to write the name and write formulas, we have to understand some of the guidelines we're going to use. And for molecular compounds, they do get a little bit complicated, so we're going to only work with binary molecular compounds. Remember, bi means 2 elements. So when 2 non-metallic elements combine, they do so in more than one way. And when I say non-metallic, I just mean non-metals, anything that's not a metal. So for example, the elements carbon and oxygen can form 2 different compounds, and both of them are gases. The first one is CO, and the next one is CO2. Now it might seem satisfactory or it might seem okay to name these carbon oxide, but you can't call both of them carbon oxide. The reason is they're actually very different compounds. CO2 actually is something that your body breathes out every time you breathe in. It's a natural process. You can normally do it. Whereas CO is actually very poisonous for you if you actually breathe it in. So CO2 is okay, CO is poisonous. We don't want to use the same name for both of those because they're very different characteristics. So in molecular compounds, we use something known as prefixes. Prefixes tell you how many atoms of the element are present. So for example, the prefix mono means 1, di means 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. If we're looking at one of those compounds, CO, mono would tell you there is a single oxygen atom, whereas di would tell you there's 2 oxygen atoms. So let's look at how to name binary compounds first. We're going to use the following rules. First, you write the names of the elements in the order they are in the formula. Next, you're going to use prefixes to indicate the number of each kind of atom. If there's just one atom in the first element, you don't have to write mono. And then on the second element, the vowel at the end is sometimes dropped when the name of the element begins with a vowel. And then last but not least, you want to end the name of the second element in IDE. Since it doesn't contain any polyatomic ions, you're not going to have an ending like ate or ite. So let's do some examples. One thing I do want to start before we start these examples is molecular compounds do not cross. Do not cross. Since they are not made up of ions, I don't have any charges to cross. This is just telling me how many I have. So here you would go through if we follow our rules first. We name our elements. We have chlorine. The first element stays the same. The second element, oxygen. But remember, the second element always changes to ide. Then we have to add our prefixes. Well, how many chlorine are there? And if you look back at that chart, the prefix for 2 is di. And then I have to say how many prefixes of oxygen are there. So if you look back at this chart, for oxygen, the prefix is octa. So, and it says octa, but A and O are both those vowels with that rule. So octa oxide. Octa oxide? Yeah. So you might misspell it. I know I still miss with spelling, but as long as you're close and you have that prefix, I'm not going to worry about it. Over here, again, you write your element first. So the first element you don't change, nitrogen. The second element, of course, you always end in "ide." And then we add our prefixes. So here our element's 2, so our prefix is di. There's nothing written here, so it's understood to be 1. And this is the second element, so I have to write monoxide. Next one, we have phosphorus. Here we have chlorine, but remember we have to change the ending of the second element to chloride. Then we add our prefixes. Well, here it is understood to be 1. But if you look at your rules, if the first element is a 1, we omit the mono, means you don't include it. So I don't have to include that. For chlorine, there's 3, and the prefix, if you look at your table, is trichloride. For the next one, we have phosphorus. And then this one is iodine, but you have to change the ending to IDE, so IO died. Then you have to look at your prefixes. This one's 4. If you look back at your table, 4 is going to be tetra. And then here, if you look at 10, let's go look at 10 again. 10 is deca. Now, deca ends in an A, and iodide ends in starts with a vowel, so both those are vowel. So we like to call this dec iodide. Okay, and the last one, we have sulfur. And then here we have oxide. We don't have any numbers written down here, so they're understood to be 1. Remember, you don't have to write mono on the first one. It has to be omitted. However, on the second one, you do have to write it. So monoxide, sulfur monoxide. So that was not too bad. If you're struggling, make sure that you're emailing me with your questions, and I'm more than happy to help you. Now we're going to kind of start with the formula. So first, to write the formula, first use your prefixes in the name to tell you the subscript of each element. Then write the correct symbols for the 2 elements with those appropriate subscript numbers that you determined. Okay. So if we were going to look at the examples here, remember, I'm going to write this again. Molecular compounds do not cross. So you read them exactly as they are. Tetra phosphorus. So tetra means 4, and phosphorus is P. So we have a P4. Tri means 3. Sulfide is sulfur, so that's an S. So S3. Here we have nitrogen, but there's no prefix, which means it's just a 1. Here we have tri, that's a 3. Fluoride is an F, so NF3. Here, disulfur. So here, di is 2, sulfur is an S. Here, chloride is a Cl, and di is a 2. Oh no, Miss Chastain, or Mrs. Grove. Can't we reduce that compound? The other thing, the reason we do this example is moleculars do not cross, and they do not simplify. So because these are made up of molecules and not a formula unit, you have to leave it as is. You do not simplify molecular. Okay. Then we have sulfur dioxide. So sulfur is an S since there's no prefix, it's just an S. Oxide is an O. And then di means 2. So SO2. And the last one, di means 2, nitrogen symbols in, so N2. And then tri means 3, and then oxide is an O, so O3. Okay. And that's the end of the lesson. Again, make sure you follow those rules. You do not simplify molecular compounds, you do not cross them, and the most important thing that gives them away is that they're made up of prefixes. So that's the end of the lesson. Let me know if you have any questions, and have a good day.